Hello everyone, am I audible? So you guys feeling starving? भूख लग रही होगी अभी? So I will very quickly wrap it up. Don't worry about it. Even I'm feeling starving, I have to go further. So I was waiting for my chance. Okay. Um, so my name is Sumit Kumar. I'm a cloud solution architect with Orange Business. So I'm into technology for over a decade. And as you can see that I am a part-time of cloud certified engineer. And I'm part of the pre-sales team, so I mostly work with the customers and understand their problems, and mostly I spend my time to design various solutions and design architecture for my customers. And I'm also a AWS Community Builder. Last year I became the AWS Community Builder, and if you get to know more about me, please feel free to scan this barcode and feel free to connect me on the LinkedIn. If you need any help, anything expertise on cloud or DevOps solutions, feel free to connect me. I'm happy to help you. Okay, so in today's, I will be talking about reliability, how to build a reliable infrastructure in cloud or in on-prem, wherever you want to make it happen. So, and this reliability part, we will first cover what is reliability and why reliability is important in the important factor of the architecture framework, and why reliability is directly linked to the customer. Means the reliability will decide whether your users are happy or unhappy, right? If your user will continue to consume your service or not, that all depend on the reliability. And then we will see various component or terminology around the reliability, right? Like the SLI, SLO, and all these fancy terms that you must be aware of. And then we will see some of the use case, like how to implement a reliable infrastructure. We will see that. First of all, how many DevOps engineers we have? Can we raise your hand? Oh, quite a lot. And any SRE in the house? Site reliability engineer? You are the SRE? Experience. No SRE? You are SRE? Okay, you are a multi-master guy. Okay. Any pre-sales architect or cloud architect? Currently you are a cloud architect. Okay, great. Okay. So as I told that these are the 6 pillars of any cloud architecture framework, not just the cloud architecture, it's a general architecture framework. And these are the 6 pillars. People who work as a SRE, people who work as a cloud engineer or a cloud architect, they know that the values of these pillars whenever you design any system design, or you just start your journey with the system design, these 6 pillars are a part of non-functional requirement whenever you design something. Right? So reliability is one of the crucial element of this architecture framework, which we will going to cover this in the next slide. Okay, can anyone tell me the meaning of reliability? I know you have seen this definition, but anyone can tell me.
As you have already mentioned, reliability means trust. For example, if you are for example, if you are like on a road at night and you want to put Ola or Uber, you have to trust on the app. Otherwise, if there is any functionality issue, you can't get so like that trust is reliable.
Okay, you're almost. So I give you an example. So reliability means trust. So if you trust someone, which means you trust that in their confidence, in their abilities, in their dependability, right? So I give you a very simple example. Let's say you have a birthday tonight and you want to order a cake. So you order a cake to the bakers, and in the evening you are going to collect the cake, and then your baker said that your cake is not ready. So all of a sudden, as a user, you will feel so angry, right? at that time you will feel so angry because your cake is not ready. Now your baker said your cake is not ready because of his oven fault, right? Oven was faulty or whatever the problem that the cake was not ready. So can you tell me whose fault is this? Is it customer or user has chosen the right baker? Whose fault is this? Can someone tell me? Yeah. Get a mic. Get a mic. Oh, continue. Continue. Speak loudly.
They say that come to the cloud, we will provide you the fault tolerance, reliability, security, everything, right? That's the and one more good thing is pay as you. That's the whole point what they pitch for us to jump to the cloud. So by default, they should be opting for that. That's a thing that pay for more advanced services or more serverless services, you get more. That's the
Yeah, you are somewhere right. Fair answer, but anyways, the customer not always that the business is fault or the user is fault. It's like the device that is faulty. I come to that point because why I'm saying that there is a cost involved, right? And how many users you are going to satisfy that your these much of users are happy. If even 1 or 2% of users are unhappy, that is fine. So I'm coming to that this part.
hosting my infra on cloud. I'm not using the on-prem. I'm going to cloud. There should be a reason. If it is not reliable, why should I go on the cloud in the first place?
No. You have to see. Reliability comes in two parts: the cost and this your service availability and their service reliability. So I'll come to that part when we coming to the next slide. So here, so you have ordered a cake. You did not get the cake because the fault was the fault of the oven, right? So as a user, you somewhere feel that unhappy, right? And maybe you will feel that you might not order the cake next time to that baker, right? But as a baker, think about the baker and think about the business. You will think about that. Okay, if I can give another cake to my user so that at least somewhere he feel reliable, somewhere he feel that he can come next time. So that's where you can satisfy your customer so that he feels somewhere reliable, right? We will see that in the context of system design. Okay. So in the context of system design, if your system is not reliable, obviously your customer will lose the trust, right? If your system is failing too much, malfunctioning every time, then what happens? This is going to be the negative impact on your customers, right? So what happens that they will lose the business, they will lose the customers, right? So reliability is very much important, and you need to consider that your service has to be very reliable in case of outage, right? So it has to be performed whenever outage happens. Okay, so reliability means that the system should be fault tolerant and working when fault error can happen. Can anyone tell me what is the difference between fault and failure in system design? Anything? No one? Everyone is reliable error? Okay, so I tell you what is the fault. In the example of bakers and cake, there could be a chance that his oven hardware device was faulty. That's why he was not able to prepare the cake. It may be possible that maybe that time the electricity has gone, or maybe the power cord of that oven was not working. So there could be a various fault. Due to that, your service was not available, and I mean in this example, your cake was not prepared. So in the context of system design, there could be many types of fault. The first type of fault, it could be a network failure, right? Let's say you have a database, right, replicating between each other, and something happens, network goes down. Whatever happened to network, your system becomes unreliable, right? And there could be a system bug, the internal design of your application, right? So your application has some bug, it could not handle the error, and it could not handle the fault tolerance, right? So this is the second fault. The third fault could be your overwhelming of resources, like you are getting a lot of requests, a billions of requests, and your system is not able to respond those requests. In those cases, you will have a resource constraint, and your system will be unreliable. And there are many more, right? So we have to make sure that whenever a fault happens, it has to be fault tolerant, so that we can avoid the failure. Because of these fault, failure happen. Okay, so let's talk about reliability in the cloud. Uh, I believe that whenever outage happen, it has to be fewer, which means your outage has to be lesser, right? And shorter means your outage duration has to be very shorter, and smaller means it has a smaller impact on your business. So this is what the reliability in the cloud. Your system becomes more reliable if it has these three things, and if it has these three things combined, which means there is a reliability of your service which are giving it to your customer. Okay, so core principles of reliability. So as per the SRE, these are the core principles. I think SRE knows better than me. These how these core principles are important. There are four core principles that ensures that there are a reliability in the cloud or the on-prem infra. I hope these fonts are visible. Quite blurry. So the first point is reliability is your top feature, which means that reliability is always a top feature. As I said, reliability is always linked with the customer, right? It's directly telling you whether your users are happy or unhappy, right? If your service is reliable, your user will stay, your customer will stay. If your service is not reliable, your users will go away, right? Your users will leave. So, for example, like you are maybe shopping e-commerce website, you are shopping something. If you get some error over there, you are not, and that service is not reliable. Maybe you will go for the Flipkart or maybe other e-commerce website, right? And then second point is reliability is defined by the users. So reliability is different for different users. So because of based on the organization, based on the business you are working, and based on the service that you are serving for the customer. So for example, I'm taking an example of let's say I'm using internet banking, right? So my reliability is I need internet banking service to be available for me all the time, so that my transaction should be processed and should be processed within that time frame, right? So my reliability lies with that my internet service banking should be available all the time. This is my the first reliability that I need. But what if I, let's say that service request or something, that car loan kind of services that these banking users always provide. So if those services are down, I think it doesn't impact me, right? So the core application, the main application has to be available. Okay, next point is 100% reliability is the wrong target. Yes. So 100% reliability is not a good thing. Is a wrong thing, because you cannot achieve 100% service to be up, right? Even the Google goes down, the Facebook goes down, right? You cannot expect these big names to be available all the times. So even our biological system, like our hearts, our biological organs takes a bit of sleep, right? So these application also takes a bit of sleep, a bit of rest, right? Okay, so these three core principles are very important in terms of SRE. And the fourth point, which is a reliability and rapid innovations, are complementary to each other, which means if your service is very much reliable, obviously you can do innovation as much as you can, right? If your service is reliable, do whatever innovation you want to do, right? And you can achieve that those innovation very easily. Any question here so far? Yeah.
Not 100%, but it looks 99% or 98%.
Yeah, that is I'm coming to in my next slide, which is a part of SLA and SLI. So basically, those percentage 99.4939s, you have been seen, right? These cloud providers are providing, right? My compute engine is 99.99% available. All these things we will see, right, in the coming slide. Yeah. Okay, this is the several factors that affect your application reliability. If you see here, there is a core application which is in the cloud, and there is some dependent application, then cloud infrastructure, then third-party application, and then you have the on-prem DevOps tool, and all this process. The first factor is the internal design of the application, which means if you have an application hosted in cloud, the internal design should be like that it has to be figure out the errors, right? Error handling. It has to be fault tolerant, right? So this is a part of kind of a software designing, right? Your system should be able to find the bugs and should be able to process those error handling part of things. Then there is a second part called dependency on secondary application or component, which means if your core application is dependent on other applications, the reliability of your core application is also depend on the reliability of the dependent application. For example, let's say you have an application hosted in the cloud on the Windows server, and that application or that Windows server wants to join to the AD server as a domain join, right? What happens if AD server gets failed or domain has some domain issue? Obviously, it's going to impact your the main application. Or let's say if your application is depending on the payment gateway, right? If someone is buying something, he has added the product into the cart, and the time he is going to pay, payment gateway failed. I mean, the payment gateway service itself failed. What happened in this case? The reliability of your e-commerce application is depending on the payment gateway application, right? So the second factor is very much important. Cloud infrastructure resource, right? So these days our applications are running in compute engine, right? Serverless engine, and we have network. All these things are hosted in cloud. What happens if this entire network goes down? What happens? Your entire application will go down, right? If you have any zonal outage, regional outage, the underlying cloud infrastructure become the dependability, right? So that is also a reliable for your core application. Infrastructure capacity and quota. Well, this is also very important because you know about your product, about your service. If you don't predict or estimate your quota for next 1 year or next 6 months, then you will be running out of the quota and your application will become unreliable. So you have to make sure that proper estimations should be in place. Okay. Then comes to DevOps part. Again, DevOps plays a very important role here because as a DevOps engineer, you are going to commit or frequently releasing the new features and update, right? So you have to make sure you use those tools which are reliable. Any mistake or any wrong tools may affect the overall reliability of this application. Any question here? No question? Okay. Coming to this service reliability, now how do we measure our service reliability for our application or service? The first part is the SLI, which is called service level indicator. So service level indicator is nothing. It is a kind of metric that I think you asked this question, right? What is that 99? This thing. So this metric is basically a proxy which you will be using to track the user happiness. So these are the metrics. You can see that here: availability, latency, and correctness, throughput. All these are the indicators. These are basically the metrics, right? Which comes under the SLI. So I give you a very simple example here. Let's say you are working on some product and it's ready for the use, and you have delivered this over the internet, and every user is accessing your application, right? Obviously, how would I define my SLI here? So I want my application to be available, right? The first matrix I will choose, and then I want my application or my user should uh, get the response in a timely manner in that frame of millisecond, like 800 milliseconds or 500 milliseconds, depending on the needs and the quality, right? It's not that you are getting the response from the application. It's not like that, but you're getting the right, and you are getting the quality response. If you are accessing internet banking application and you get a response in let's say in JSON file, in XML, would you understand? You won't understand, right? You need some quality level of data, right? Then you can interact with them. Okay, and second example is if you are offering a data processing or ETL services to your customer, then what would you define? What is your metrics level? Your metrics level will be coverage. Means you want your data to cover, you want your data pipeline to cover the entire data, right? And you want that the data has to be correct, and the throughput, right? How much data I can feed it just a one time, right? So you need all those metrics. And storage, like let's take an example of S3. How much throughput, how much data I can upload it at a one time, and the latency has to be low. So those kind of metrics I will select here as per my needs. Right? Now coming to your question, the availability, this percentage part. Then we have SLO, which is called service level objective. So SLO is nothing; it is a target value of your SLI, which we have just discussed here, availability, latency, and all those things, and below which, if the target value for the SLI, below which the user is considered to be unhappy, right? So let's say if you are saying my application availability is 99.99%, if it is below that, your user will be unhappy, right? If you continue to serve at that target, then your user will be happy. So you have to maintain that. So how do you set it? So it will be agreed. It is a kind of a documentations or advisory that will be agreed upon by your internal developer teams or maybe SRE and executive members. So they people decide, okay, this much of SLO I want to decide for this particular SLI, and usually it defined in a percentage. Examples are, let's say I am defining SLO on the availability of my service, which I am saying 99.99% of requests should return 200 or should process. If my 0.01% user doesn't get a proper response, that's fine, right? Because I am giving 99.9% of requests, which is agreed. Similarly, in terms of latency, 99.9% my request should process within that time frame, right? And even the remainings will not process in that time frame. That's fine. SLA, service level agreement. So this SLA, I think everyone is heard about this term SLA, right? Can anyone tell me what exactly is the SLA? I'm asking to the experienced person, like.
So SLA is something as in a legal document wherein you have mentioned that this much time.
It's not legal.
But it is enforceable. At times it is enforceable.
It's not.
Yeah, but you can make it. That's what I have seen with one of our clients. He was a fintech client, and they specifically mentioned that this would become a legal document, and if it breaches, you would be liable to pay certain amount.
Right.
So
the agreement we does have this type of clause.
It's a legal agreement, by the way. It's a legal.
agreement.
Yeah, it's a legal agreement. The SOW, whatever you signed, I think we're talking about the SOW part, which is another level of debate. But as of now, just treat SLA as a legal agreement. What happens that there is a contractual agreement between customer and the service provider. If you are not able to deliver those services, whatever we have agreed, there are some penalties that you have to be liable for that. So as of now, just understand that this is a legal agreement. Something happens, then someone has to pay this. Recently, something happened with the Google Cloud. Some customers' database goes down, and Google has to pay this penalty. So let's talk about SLA. Again, it's agreed upon between the external customer and the cloud provider. And for example, let's say in Google Cloud or AWS Cloud, Google Cloud is saying that you can use my compute engine, which is I'm giving you the 99.99% SLA. So which means even if there are outage, you will be continued to serve, right? And same for load balancing, right? Google Cloud providing a load balancing or any other cloud providing this kind of SLA agreement that this much of percentage will be available all the time, right? Depending on the metrics and depending on the SLI for that service. Any question for the SLA? Yes?
So let's say some customer or some user fall under 1% of the criteria where service won't reach, right? How does they reach out? I mean, how they will know that I was in the category in 1% and the other customer success rate was 99%?
How does customers know, or how does
customers will know that I should get compensation or something if the SLO is not reached?
No, for 1%, no, you can't take for 1% as a compensation. You have decided 99.9%, below which I told you, right, the SLO part, below which that threshold, then you will be liable for the penalty, right? Then that provider will pay you. As long as you are serving 99.9% request to the users, I think you are good, and nobody is going to.
That's all. So let's say if my service, I'm trying to continuously trying to hit a service, maybe an API, right? It should give me 99.99% time response. Let's say my service is only giving me 98% of response, 2% it is failing. So it's not falling under SLO. I mean, it's falling under SLO, right? I should get 99%.
Yes.
So how will I track that? I mean, is there a metrics or dashboard? How it will be tracked?
Well, it has to be some kind of a automation in place, or there is some provider also provide this SLO metrics tool. I mean, Google provide this tool, SLO tools. So you can use those tools and track that, okay, this much level of agreed request I'm getting, the like availability I'm getting, or the latency I'm getting. If you see that if you have a data and you're not getting those kind of deliverables, then you can obviously talk to your service provider and go for your refund back or whatever. Right? Again, reliability is itself a very huge topic. It's applicable for everyone. It's not just that you are a DevOps engineer, you are a development team, or is a cloud architect or SRE. No, everyone here is working to build your infrastructure reliable in any part. DevOps engineer is doing with their code with the DevOps tool. Cloud engineer is doing to make their operation smoother, right? And the dev team is working on making their code is in such a way that it do not have a bug, automatically have a fault tolerance. Database team is again working on the replication team, sharding and all those things, right? Everyone working that his service, his underlying tech should be reliable, right?
So basically, there are scheduled maintenance times as well, which organizations take. Right? So let's say in the whole year, you can take downtime or accumulated downtime of let's say 1 day, or let's say 46 hours, 48 hours, or whatnot. So in let's say a whole year, you give this much amount of time, which I'll use for a maintenance time or for a downtime or for a scheduled upgrade of infrastructure. In that case, that counts inside your timing which you have given. Again, now if there's an outage or there's downtime or incident, that also comes inside that. And whenever you give a notification to the customer that my service was down from so and so time, or the customer notices it by themselves, then as well it comes inside the downtime. Now it's kind of a blurry line कि customer को पता ही नहीं चला कि breach हो चुका है, but it happens actually कि कई बार ऐसा होता है कि downtime is way more than what happened to what is signed in the SLO. But if the customer is aware enough and the finance team is wise, they will get penalty from you.
हाँ, इसमें एक चीज है कि जैसे आपने जो भी एग्रीमेंट किया है उसके लिए भी अभी मैं आगे इस पे बात करूंगा कि बजट क्या होता है, राइट? हाउ मच डाउन टाइम you can afford for your customer. That is why you people are, DevOps team are releasing. If something happens, your customer is aware that if something happens in that time frame, it has been agreed, right? So you have to save those, those affordable time, right? So I'll talk about that. So measuring service reliability again, there are in a different angle I will talk about.
Yeah, I have something to add here. To his point, basically, if you want to track SLO, there is a open source tool called SLO generator provided by Google. So if you it provides basically so whatever tool you are using to scrap your metrics, say Prometheus. So you SLO generator has basically two config files. You can provide any metric URL. It has support for almost every big organization, say Prometheus or Datadog or New Relic also. So you can provide the config in those SLO generator files. And if you SLO generator, if you hit the command of that, it basically comes with CLI also. SLO generator has CLI also. If you hit that command, it basically generates the report. Calculating the SLI, it has an SLO that you mentioned defined in the config file. It also has a gap value. Basically, this is the SLI minus SLO. So that is, if it is negative, then that is problematic because SLI should be greater than SLO because we cannot afford downtime. And there is an error budget that he mentioned that he'll be talking about. So error budget is something very interesting.
Just one more thing. ये 99.9%. So this 99.9% might look very good, but if you actually calculate it in minutes, it's like 5 or 6 minutes per whole year.
It's going to cost them.
Yes.
If you go for 4, the number of nines will grow, the cost will also grow.
Yes. Like when S3 says 11 nines, 99.11 nines, that's seconds, milliseconds in a year. If that goes down, think of the penalty charge around that.
I mean, there is a not like that there is a latency. I mean, if you are taking this SLI into this consideration, then only you will latency should be low. Anyways, let's continue talking about the error budget. Now we have talked about that 100% reliability target is wrong. It's absolutely wrong. Even though it is desirable, but in the real time it is not achievable, right? It is 100% not achievable. So what happens if allow for app downtime and slowness? What happens that if your that 1% or 0.01% you are afford to lose for the downtime or the slowness, that comes under the error budget. So basically the error budget is saying 100% minus SLO, and it is calculated as per minute or the request. So I told you, right, if you are saying your application or the availability of your service is 949, then 0.01% is your error budget, right? So for example, if SLO is 99.9% of the request return successful status, then the error budget is 0.1%, which means only 0.1% of the request can fail over the course of a month or quarter, right? So for example, let's say you have a Google search service, maybe it's running over the year or over the quarter or 6 months, and due to some outage happens, whatever outage you have, budget of 50 minutes, let's say it's 99.99%, then the error budget is 50 minutes over the year. So you can lose 50 minutes of downtime and slowness. This is what you have the error budget. In that error budget, you will be rolling your features and everything, right? Then we have something called error budget policy, right? Now, what is error budget policy? It is basically some of the document or some of the action that is taken by the organization to improve the stability when the error budget is going to be exhausted. So in this case, what happens if your error budget is exhausted? Let's say that Google search engine is exhausted over 50 minutes or more than 60 minutes. Then what happens? How do you decide that there should be some error budget policy and everyone has to follow this this policy? So what happened that in that case again, stakeholders from various teams like business executive, DevOps, development teams, all these teams agreed and decide that we have to reserve some error budget policy, and we should reduce the frequency of the new release so that in case of extra cases, freeze the release or the product future. So basically, you need to be aware that you have to be carefully release your new features to the application. So that's where you can preserve the budget policy. So critical user journey. So most of the time people ask that, okay, if I have to make every service to be reliable, then it is going to be very costly, right? Because now you have to have a duplicate copy of the services. So what is critical journey? Critical user journey, that not every services is critical for you, right? You have a internet banking application. If I give you the example again, the transaction, view balance, and sending the payments are your critical user journey service, right? But if you're talking about the loan or service request or other services like reward services, that is not a critical journey. That will not fall under the critical journey user, depending on again the business need. So what will happen that you will make sure that your core application, your transaction application, has to be reliable. So you can put extra cost, right? As I told you, if you make reliable every service, it is going to be cost much, right? So here you need to take a decision, and these are the example like banking and the online shopping. Quickly just cover it. And how to minimize the duration and the frequency of outage. So this is the life cycle of how when the this understanding the production incident life cycle. So here you can see that the user has a reliable and he was happy, and the moment that the outage begins, at the moment that the support teams pick those tickets, it's called a time to detect, right? And then once the remediations or solution started and the issue is mitigated, the time frame between it's called a time to mitigate. And then there is another outage happened, which we call the time frame is called the time between the failure. So we need to avoid those outage frequently. If your system is giving more outage very frequently, your system is not reliable at all. So we need to avoid this. We need to use a proper handling tools, right architecture, right, all those things, so that our system becomes reliable and less outage. So we pass this here. So this is a case study. We can take it as, let's say, if an enterprise manufacturing organization is looking to modernize their on-premises supply chain platform with cloud or Google Cloud. So we need to make sure that these are the priorities of this manufacturing company wants, which is no single point of failure, maximize the business continuity, and then the visibility of the performance of your services and systems, and auto healing environment, no performance bottleneck. How we can tackle this? So here you can see that, I think this is blur, but just try to understand that this is a overall an architecture which where this manufacturing company has a load balancer, a regional load balancer. You can say here, why regional load balancer? Because if I put a global load balancer, it is a single point of failure, right? If I put a global, because even though it is a managed service, but who knows? If this is down, then down, your entire application is down. So I put two regional load balancer in two different regions. And then, so I have no single point of failure here. We have a multi-zonal architecture and multi-regional architecture. And then for your business continuity, right? Like DB sync replication for RPO. So this is your database instance here. And you can see that this cloud spanner I am using, and this is a multi-regional. So even in case zonal outage or regional outage, so I am avoiding disaster outage. I have a business continuity in plan. In case my DB is getting syncing and replicating with the other DB nodes. So in case of any disaster happen, then we can bring our data back, right? Auto healing, it's like a auto scaling OS clustering, right? You must be hearing about the auto scaling, right? We set up the auto scaling when you get a number of requests. I mean, overwhelming, your system is getting overwhelmed with the number of requests. How do you scale it in terms of CPU and memory? You're gonna put some auto scaling. It will grow horizontal scaling and it will grow auto, that vertical scaling. So all type of this auto scaling should be in place. And apart from this, OS clustering is also matters in terms of Microsoft failover cluster, right? You must be hearing about Microsoft. If people are working on Windows, then we set up TFS cluster or DB cluster, right? All these flavors are comes in the OS level clustering. So this is kind of a auto healing. Okay, no performance bottleneck, CDN, right size instance, all these things. So to improve the performance, you can use CDN, right? Content delivery network, which is nothing that Google, most of the cloud provider provides, right? So that your users will be able to get the response from their nearest location, right? They also called there are many caching technology like Redis cache and all those things, which will give you some sort of performance. I mean, can help you to get down to the bottlenecks. Okay, any question here? Yes.
Do we consider DNS outage in reliability?
Very good question. Yes, definitely we consider, because DNS is actually managed by the cloud provider, and DNS is also managed by the different provider like GoDaddy and all these things. So your DNS reliability is now is on the service provider who is giving you the DNS services. Of course, it is a part of. Yes, yeah.
So, what recently happened Cloudflare went live.
Okay. Mm-hmm.
Give you context.
So to set the context, the Cloudflare was having a downtime, and Cloudflare hosted all of our DNS entries and everything, the CNAME, JNAMEs and everything. Now, as Cloudflare is down, the customers in that region also couldn't access our services because DNS couldn't resolve. TTL was 5 minutes at max. After 5 minutes, every DNS got filled. Now, in this scenario, because our services were fine, but Cloudflare was down itself. Now, yes, Cloudflare was offering us the SLO and SLO and everything, but again, our customers were impacted. Right? But that was not because of our infra, because we are using third-party infra.
That's why I said your application, your core application dependability on the external APIs and the other services. The reliability of those services is also the overall reliability of your application. Right? So you have to check with your Cloudflare. Is there any penalty you can get back? Because right, there are some error budget policy, as I told you, right? So they will also maintain some error budget. If it is down for 15 years throughout the year, then you are not breaking the agreement, right? Because they already told you, right? This is 99.99%. My service will be available. But if it goes down 1%, you can't ask me for the refund or whatever, right?
So basically, what all services we use in the cloud, we need to include all the, I mean, like SLS for them as well.
Simple answer: 100% reliability is the wrong target. You cannot achieve 100% reliability. Even Google goes down, right? Right? Even your internal organ sleeps, right? How can you expect the materialized thing to be available? Okay, so I'm gonna wrap it now. So you can scan this again if you want to connect. If you have any questions, you can feel free to connect me offline or during the lunch.
Can we not avoid downtime with this solution? कि जैसे instead of upgrading the infra which is there with the cloud service provider, the whole infra should not be upgraded or maintained at the same time. Let's say our application is hosted on a particular region. For the time being, when the maintenance for that particular region is being taken care, you can host that to a region which does not require maintenance. Are you getting the point?
Not exactly. See, if we're talking about the reasons are termed for a primary reason or secondary reason, right?
The context was around the geographical location where my application is hosted. If that needs to be maintained, if that infra which is on that particular geographical location needs to be maintained, why not my application should move out from that particular location and be hosted on another location just for the time being?
If you can spend more, if you can spend dollars, yes, you can get it. You can go for the active clustering, or you can go for the active redundancy. You can get the same, but normally it doesn't happen. You cannot route the request. Let's say you have a two reason A and B. Your request is coming to reason A every time. Reason B is just for your disaster recovery, and there are lesser number of resources just for in case of anything happens wrong. What happens if a reason A goes down? Then only the request will be routing to the reason B, and there, with the help of the DevOps team, the proper tools and things in place, you will scale it. Otherwise, if you want to go for the active approach, and if you go for the maintenance, see, maintenance is not like that your reason is go down. You have a zonal risk as well, right? And you have a downtime. Not every release needs a downtime. Right? To go for the canary deployment or many other deployments, they don't need it. What I'm saying, the downtime means if something goes wrong, any outage happens. Let's say your code has some bugs. Google, like you say, Google search or YouTube was down. That's Google. Do you think they are running out of resource? No. Something issue happened with the DNS, right? So I'm talking about the outage, not this business continuity thing.
The outage might not necessarily be because of the infra itself. There can be another reason for that.
Yeah, it happen. I told you, right? There are multiple types of fault, right? Internal design, network, so many things. Maybe the code is not that much, deployed. So you can. Okay. Thank you so much. If you have any question, we'll take it offline because I'll have to leave for Jaipur. Already getting late. Thank you so much.